Now, to help us answer this question, if there's a relationship, right, and that an explanatory variable causes a response variable, right, somehow it controls the outcomes in that manner, is we have to then again distinguish between observational studies and experiments. And an experiment, right, is where there's some treatment done to an explanatory variable. There's some random assignment to groups. We control for these groups. We really try to make sure that we have similar groups that we can compare. And that's the purpose of an experiment, right? We impose some treatment and then measure the effect of these treatments. Versus an observational study, right? In observational units, it's kind of more like a sample survey. You're collecting data, you're asking people. You're not imposing any treatments on people or things or giving them things, right? Where this experiment deliberately imposes some treatment on individuals, right? They're given medicine, they're given tutoring, they're given computers, and we're seeing if we give them this, how does that compare to another group of similar people who don't have that, right? And then we look at outcomes. And those individuals are called the units, right? An observation unit or an experimental unit, right? Depending upon are they part of an observational study or an experimental study, an experiment. We see an example here of trying to come up with given a situation and determining this is an experiment because there's random assignment in the sense of you have 15 computers that were random at random, and then they were their brightness settings were changed, and then we measured their battery life. How long did they live to see if there was a difference between these two, this explanatory response variable relationship. This would be a simple experiment versus this observational study because of the sample survey, no treatments were imposed, right? Families who were surveyed are the observational units in this case. So it doesn't have to be a person, it's the families that in this case, right? But the group or things or individuals that were being surveyed. So this is an example of an observational study versus an experiment. Now, there's some other terminology here that we want to pay attention to. And it's the idea of a lurking variable, right? And this idea of confounding. You may even hear a confounding variable, but a lurking variable is a variable. Lurking, it's like something that's hiding out there that you're not aware of, right? And so sometimes when we look at data, there's a lurking variable, something we haven't considered, right? But may influence the response in some way without us knowing that. So when we conduct studies, we have to always be aware of a lurking variable, something that we haven't been thinking about that could have influenced the outcomes of our studies. And confounding occurs when two variables are associated in such a way that the effects on a response cannot be distinguished. Now, confounding is the idea that we have two variables, and I'm not sure which one is the actual one. They both seem to be doing it, but I don't know which one is actually having influence on the response variable. So we have some confounding occurring, right? We're not sure, right? And that's slightly different than what we call a lurking variable as we think about it. And can you think of a lurking variable that may be confounded with whether or not a family eats together, yet affects student academic performance? That was in example number 5 here. Now, when families eat together, it could be really not, eating together really is not the thing that influences academic performance. It could be because parents have good jobs, which allow them to be home on time to eat, right? It could be income level. It could be where they live, right? There's a lot of things other than just eating together that could affect that. So keep that in mind with that discussion there.